So 45 minutes, this is excluding questions. Um, Towards the end of each session, you can ask your question, or along the way, when I'm presenting, you can just write your question in the chat. I will answer it once we are done with the webinar. So without further ado, let's go ahead and start talking about Python. For people who are joining from YouTube, I will try to answer the questions that pop up in the live chat area. So if you have any questions, people are watching on YouTube, you can ask there. I will try to answer your questions. Okay. So Python. I bet a lot of you guys have heard about Python at least once or twice. I'm sure that some of you guys have already have some experience in working with Python. Others just heard the name. So Python is a programming language. To the surprise, it's not that new. Python was released in 1991 by a guy called Gudevan Russom. The Python for whenever it was created, it was just a regular programming language. However, as the years went by, the development of Python have processed or evolved so much that it starts getting into a lot of industries. One of the industries being oil and gas. Python can be used for web development, server side. Actually, this is changing currently with the release of Python script in the upcoming months or upcoming years. Python is expected to replace JavaScript. By the way, this is just a speculation. You can do software development with Python. You can do mathematical calculations. You can script your system, maybe automate some stuff in your Windows or a Mac or Linux environment. For definitely, you can use it for data science, working with data analysis. You can use it for engineering, design, computation, and you can use it for oil and gas industry as well. There is a lot of usage for Python. It's not going to do the justice just to mention these, but we are short on time. So Python currently is being used in a lot of industries. One of the industries we're concerned about is the industries with engineering design in mind. For example, automotive industries, oil and gas, chemical engineering industries, food processing. All of these industry actually they use Python to design their workflows, design their monitoring capabilities, and to monitor their assets they have. So you can see Python is very diverse and it covers a lot of industries. So what's the benefits of using Python? Actually, using Python has a lot of benefits. First of all, it's very easy to learn. You can actually write fewer codes in Python than other languages. Actually, we take a comparison in the next slides. Python has huge support from the community. By the way, for the people who are not programmers, support is very, very important in programming languages. For example, whenever you have like a technical issue in a programming languages, like any workflow you don't know how to do or you're not sure about, what you do actually what programmers do, they usually seek help for that. For older programming languages like BASIC, Fortran, maybe COBOL, these languages, they have less support. So it's probably you will run into an issue and you don't know how to solve it. And this is not the case with Python because there's a huge community of millions of people who are using Python. Additionally, Python has large number of free libraries we can use. These libraries actually you can think of as already built-in functions by other users for you to use. So you will leverage the work hours that been done by others, and you can incorporate that into your applications you write in Python. Uh, in that way, you will assure that you don't have to recreate the wheel, and you are using a standardized package or a standardized library. As we said, Python is easy to learn, and we will see in the upcoming slides why. Plus, sharing code is very easy. For older folks, they know that older programming languages, they have compatibility issues with different operating systems and different processors. This is strictly true for older programming languages. However, Python is available almost everywhere. For example, you can use Python on web. There are websites that provide Python, like a Python compiler on the website. You can use that. You can use Python on mobile, Android, iOS. You can use it on Macintosh, Linux, Unix, embedded system, whatever system you think of, actually Python can work on. So this is a huge plus for a lot of people. Plus, one of the good things about Python, it has a lot of libraries that's designed specifically to target oil and gas industry. So let's talk about some tools that can be used in Python. Python comes with this basic tool. This is known as idle. This is right off the bat. This is provided from the official website, Python website. Let me show you. So if you go ahead and just type Python in the web browser, you will get this. There's a website called python.org. This is the main website that provides Python. If you go into that website, and you can download the Python. However, this website, when you download Python from it, it does not provide you with all the libraries we are going to use for oil and gas industry programming and stuff. Additionally, it does not provide any integrated development environment. So alternative, we can use another thing that's called Anaconda package. It contains Python and a lot of libraries and some IDEs we can use. So some Python packages comes with something called Python IPython or interpretive Python. This is a small interpretive tool that you can write your equations or you can write your statements in it, and it returns the results right away. So it's shown in front of you guys. The green lines, actually, those are the inputs, and the red lines are the output. So this is very similar to something called Jupyter we'll talk about in the upcoming slides. So this is one of the tools. This is known as IPython. Almost all IDEs have this. So if we launched Python idle, Python idle, by the way, is the tool that comes with Python when you download the Python from the main provider, python.org. So this is known as Python idle. Whatever expression or whatever things you write here, you will expect the results right away. For example, you can just write print X, so it gives you the result back. So this is known as interactive Python or IPython for short. Currently, not a lot of people using idle. Most of people, they are using something called integrated development environments. These type of environments, actually, they are more sophisticated. They have a clear way of structuring data. They can provide source control of the code, and additionally, you can integrate them with the packages like Inthought Canopy and Anaconda. So IDEs are widely used currently. Some examples of the IDEs, you have Spider, sorry, you have PyCharm and Visual Studio Code. Personally, I have all of three installed on my desktop. However, I use only the first one and the last one, Spider and Visual Studio Code. And by the way, you can choose any one of these you like. So we talked about how downloading Python from the main website does not have all those IDEs and all those libraries we need. The solution to this is to download a Python from a website called Anaconda. Anaconda is a Python package or a distribution of Python that contains all the IDEs and all the libraries necessary, and it makes the life easier. So you will only download a package, a single package as extension of exe, and then you install that. Once that's installed, it provides you with all the libraries you need. To download Anaconda, what you need is you need to go to this website, type in Google Anaconda Python, go to Anaconda distribution, and this website will be apparent in front of you. So it already detected my system. It's a Windows system. So you can go ahead and download Anaconda for you. Once downloaded, the file is almost 600 megabytes. Once you install that, you will have mainly you'll have three things. The first thing is you will have Python installed on your PC or on your desktop, so you don't need to go ahead and download Python again from the official website. This is one. The second thing, it provides you with the required development environments, for example, Spider. The third thing, it will provide you with hundreds of pre-built libraries inside the package, so you don't need and go ahead and just start installing the basic ones. So this is a great place to start, especially for beginners. So we already said Anaconda comes with large selection of libraries. It comes with Spider. This is known as IDE, or some people call it, this is a text editor, but it's both. It provides you as well with Petroleum. Petroleum is basically a web-based software that can be used to write Python code. And it provides us with a package manager. So let me show you what a package manager is. A package manager is actually a small software that's built by Anaconda guys. That what it does actually, it pulls out libraries from Python in the package indexing website. So there is a website called PyPy. This is known as Python in Package Indexer. So this is the main website where you get your Python libraries. So this is the main website. You can see currently on the website, there is something close to 400,000 projects uploaded on the website. This website actually includes all the official and non-official packages for Python. For example, if you want to search a package that's called, a library that's called Pandas, you just type the name, wait for the results, and once the results are returned, you can select any package you like. For example, the Pandas package, the official Pandas package was updated last time on June 23rd, 2020. Additionally, it provides you with the link to the GitHub page, or how to or link to the documentations and all the necessary and required changes that have been happening to the library. Additionally, it can provide you on how to install the library and how to use it effectively. So this is the benefit of using a Python index packaging website, PyPy. So the package manager or the or package management tool that's provided by Anaconda actually pulls out a package directly from that website. This is we will share the PowerPoint with you guys, so you can just go and follow this link to download Anaconda, and it's It's provided for the 32 and 64-bit machines as well. So let's cut to the chase. Why and how you should learn Python? Why you should learn Python in the first place? There is a lot of programming languages that already exist, but why you should make the decision to learn Python? So this is a very important question we need to answer. One of the things, not a lot of things, no, it's just one of the features. One of the things is that a lot of oil and gas companies who provides software services like Schlumberger, Paradigm, people like Petroleum experts, they are shifting towards Python. So they are building their APIs, or they are building the way you can communicate with the software. They are building it and targeting it toward Python. So you will see currently softwares like TechLock, which is a petrophysics package provided by Schlumberger. It uses Python as its main programming languages. So you can write Python scripts to interact with well logs that resides inside TechLock. Recently, the shift has changed in Olga. For Olga, you need you in the previous years, you need to write codes in Fortran and C++ in order to interact with Olga, but in the current releases, they have shifted to Python. You can use Python codes to interact with PipeSim software as well. You can use Python to interact with Petroleum expert softwares. This is all the softwares, Prosper, Gap, Embal, Reveal. So all the important softwares, PVTP, all the important softwares that provided by the Petex guys, you can interact with them using Python. So as you can see, a lot of companies have been shifting towards Python. So what solutions can we do with Python if you are not willing to connect to one of the softwares we've just talked about? So there is a lot of things you can do. You can connect Python to database servers that contains oil and gas data, and start creating a, let's say, a multi-phase measurement or multi-phase meter dashboards with that. So that requires some form of programming knowledge, and Python, it can provide you with that base to start doing your modeling. So a lot of things you can do with Python. So currently, one of the more advanced things have been being done using Python is creating virtual production systems. So what a virtual production system is just a regular production system like a well, a reservoir, surface networks, and what you do is you create these models with any one of these softwares, industry standard software. It can be a dynamic software or steady state software, and you link that with Python, and Python can pull data from SQL servers or any data container, and then it can read data as well from digital oil field. What you can do is you can plug all of this information inside Python, and you decide the route of the data. You can update the models as they exist, or you can just perform some calculations and report those calculations back inside a scientific dashboard or inside a analytical dashboard. So there's a lot of things we can do with Python, but however, this is like a more advanced solution. I just wanted to show you guys what are the limits of Python. Actually, there's no limits to it. One more thing you can do is you can create a well management package with it. A well management is any code script that can manage multiple wells at the same time. For example, people who are working in production engineering on subsurfaces, what they struggle with is there's the need and there is the urge to dedicate some time. This time can be ranged from hours to days to update the existing models, existing Prosper or PipeSim model. This is time consuming because you need to update those model and review the results as they are coming out of simulation. Luckily, you can use Python for that, and you can automate it. So for the work that's maybe, let's say, it consumes 3 or 4 hours, if you have already written a code for that, you can perform it in multiple or many in few minutes. So it all depends on the types of solution you are targeting, but the solutions in Python are just limitless. So let's see what are the libraries that are targeted toward oil and gas industry in Python. Actually, there are multiple libraries. I am only mentioning a few libraries for the for this slide. So there's a library called Lasio. This library actually shows or handles LAS and LS files. It targets geoscience and petrophysics, but production engineers can use it as well. There is a library called Fluids. This is a multi-phase flow calculation library. It provides some nice correlations. You can use it to check the stability of wells, pipelines, and whatever flow components you have in the field. So it's very beneficial to production and flow assurance guys. There is another nice library I really like. It's called PZAPI, or Production System Optimization Library. This library actually provides you with the VLP correlation, so you can do nodal analysis with that. It provides two correlations only, Beck-Zembrel and Hager-Brown, but you can do a lot of things with that. There is another library called WellPath. This is to create 3D well paths. So this can visualize and create the path for you using multiple methods. There is another library called CoolProp. CoolProp actually is a PVT package or a thermodynamic package that uses equation of state to calculate different properties of oil and gas and water. So people's like reservoir production and flow assurance guys can use this package. There are many packages that I haven't mentioned in the slides because they are maybe in hundreds. There are some packages even we don't know about. What you can do in Python, actually, you can leverage all of those libraries and you can create your own library. So all of these libraries, actually, you can download and read the code for it because it's open source and it's free to use. So there are some more libraries in Python we use in oil and gas industry on day-to-day basis. Those are more general library, but they are they come in handy. For example, we have a library called Pandas. This is this is very useful if you are willing to work with data tables. There is another library called NumPy. NumPy is a numerical library. It provides you with a means or ways to work with arrays and any transforms and manipulation that's happened to that array. Actually, you can use NumPy for that. There's another library called Matplotlib. This library is a plotting library. There is another library that's fairly recent. It's called Dash. Dash is a dashboarding library for Python. So you can use it to create analytical dashboards for your production, injection, or reservoir monitoring purposes. There is another library called Plotly. Plotly is the same as Matplotlib. Both of these are used for plotting. There is another library I like a lot. It's called Streamlit. This is similar to Dash. You can use both to create dashboards. However, Streamlit, it's much easier to work with than Dash. There is another library called scikit-learn or sklearn. This is used for machine learning and artificial neural networks. There is another library called SciPy. This is a scientific library. You can use it for data interpolation and data management, filling missing data, and a lot of stuff. It has a lot of capabilities. You can use it to generate data trends like polynomial or linear regression. So it has a lot of capabilities. There's another library called PyXL. This is a library, as the name implies. This is used to connect with the existing SQL, existing Excel files. So as you can see, these libraries actually they are more of general library, but however they can be used to leverage Python and uh, maybe create some custom solutions in oil and gas industry. So those were the slides. Actually, the programming languages I tend to not to create a lot of slides because the way you leverage or the way you understand programming language and how it can affect your work or how it can be beneficial to you is to start using it. So we will start taking some examples. Let me pull up the example slides. We will try to take 3 to 4 examples if it's possible. So we will take 2 examples today if we can, and another example tomorrow. So okay, so these are the practical examples we will try to cover in this webinar series of 2 parts. So the first example, we will take a look at how to generate some valuable results using PVT equations or PVT correlations to be precise. So we will try to convert the standings method in calculating the solubility of the gas, or known as uh, gas solubility RS, and convert this into Python code and hopefully generate a plot like the plot, a similar plot to this one. Okay, so you can convert this to this plot. The second example will be is to generate this type of data or this type of contour map. This requires actually some data. I will provide this data as well for you guys. And what we will do tomorrow is once we get a good grasp on Python, we'll try to create something like this, a production dashboard using Vault data. I have the production dashboard. It's already running on my website, or sort of on my browser. So I will show you like a live demo of that. Mhm. So you should be now seeing a my browser. So this is called a production dashboard or field monitoring dashboard. You can name it whatever you like. However, this is basically used to monitor production or injection from wells. What I'm doing actually, I am pulling data from Excel sheet and plotting all the variables as a function of time. So you can create this using Python. You can add any level of complexity you like. You can view only a single well. You can expand the plot. Actually, you can do a lot of things with it. So there's a limitless capability of what you can do with Python. So let's go ahead and start with a basic example. So in order to use Python, first of all, we already agreed on you need to download Anaconda from their website. Okay, once you download Anaconda, Anaconda comes with a software that's called Spider. It's written like this, Spider. So this is the icon. So you just go ahead and launch this application. Additionally, what you can do is you can install another software that's called Visual Studio Code. This is the software. Actually, you have to go and explicitly download the software because it's not included in Anaconda. However, it's very easy to download. There's something called Anaconda Navigator, which you will get once you install Anaconda. You open this and you go ahead and download the Visual Studio Code from there. So now, as the Spider have launched, this is the basic IDE for the Spider software, which is used to write Python codes. Just wait for it to finish loading all the necessary items. So let me introduce you a bit about the software. So on the pane on the left-hand side, this is where you write your code. So your code is written here. So you write it as lines. Okay. Okay. Once you're done writing your code, actually what you need to save it. So this is the button for it. You can save it or you can save it as. If you want to run the file, you click this button. This is run file. Once your file is run, the result will show in this area. This right-hand side panel on the bottom, this is known as the Python console or interactive console. We already talked about this. This is known as IPython. There is another thing called variable explorers. Whenever you write variables in this sheet, it already will be shown in this tab. So let's try a few things. So let's go ahead and create a generic variable that's called x. Let's assign x to something like 100. So when you run the software, you see there's something now appears on the variable explorer. It's called x with a value. Okay. However, the console did not show us any outputs. And this is for a good reason, because you need to explicitly print this. Okay. This applies in Visual Studio and Spider. If you are using softwares like Jupyter actually prints it for you directly. So in order to print any value or any message you like in Python, you use a keyword called print. So the print is written like this, and you open and close brackets. Okay, so sorry, you open and close parentheses, and between those two parentheses, you pass whatever parameter you like. For example, I am going to pass my x value to it. So I click run. Now I am getting the 100 value. So sometimes it's nasty to just get the number 100. You need to include message with this as well. What you can do is just delete this x and write whatever message you like. To write a message, the message is going to be a string. So to define a string in Python, you open and close this quotation, single quotation or double quotation. It's the same in Python. So these two are the same. You can use whatever one you like. So I will just write your x value is, and then to pass the x value so it can appear next to the message I am providing, I will just type comma like this, and then I pass the x value to it. So when I run the software, it shows me this message, your x value is 100. So this is how to basically work with print. You can write equations in Python. For example, let's write an equation that takes multiple variables. Let me define another variable, or declare another variable to be precise, as y equals to 500. Maybe y, let's say y2 equals to 300. Let's define an equation that's called z. So x plus y divided by y2. So this is the equation. Whenever I click run, Python actually is evaluate these lines and calculates this one. And then I want to print the results for the z equation. So let me just modify my print result slightly. I will just modify this. Your Z value is, I will replace X with the Z. So whenever I run, now you should get your Z value. Now this is evaluated once I click run. You can see the variable explorer is already updated. So these are the values you have declared, and now it's summarized here for your review. This is a very nice tool inside Spider. This is the variable explorer. To my knowledge, there are some other equivalent features like variable explorer in other IDEs, but however, from the looks of it, Spider actually is the most versatile one. So let's go ahead and introduce you to one of the data types that known as list. So basically, what a list is a one-dimensional array. So this is what a list is. How to declare list? You need to write your first of all the list name. For example, I am going to declare a list known as production, or let's name it oil production. By the way, if you are new to programming, sorry, the variable name in Python can be uppercase or lowercase, and you can mix and match between those. Python is case sensitive, so writing oil, it's not the same as writing oil like this or oil like this. It's not the same. So because it's case sensitive. Additionally, you cannot put number in front of the variable name. This is not correct. You can add numbers after first writing a letter. So writing oil production like this is correct. However, you cannot put any number in front of the variable name. This is not correct. So let's declare a list, or let's say it's an array that contains multiple production data. It can be 2, 3, 5, or 10, or maybe you're pulling data from database. So to declare a list, what you need to do is open and close bracket. In Python, this means the oil production is a list and it's empty because you did not provide any data between these two parentheses. Sorry, between those two brackets. So to get to know the type of data or the type of variable inside Python, you type this this keyword. It's known as type. It's written like this: open and close parentheses, and then you pass your variable name to it, which is oil production. So let's go ahead and print this one. Let's see what's the type of the oil production. Just click run. See, it's telling me this is a class and it's a list. So this is a list. This is how to know the type of the variable. So let's populate some data in this. I will add some random data in the production. And you separate the results using comma. Now that I've created this list, which contains 5 values, let's create another list that contains the days of these measurements or the days of these readings. So I will name it oil underscore days equals to, let's say this is day 1, 2, 3, 4, 5. Instead of days, what you can do, just writing typing 1, 2, 3, 4. Actually, you can provide something similar to date time like this. Let's say 2020. Let's say 2021. So something like this. You can do both. The good thing about list, you can add as many variables as many entries as you like, and it can be any type you want. It can be strings, it can be date time, it can be floats, it can be integers. So in order to convert Python integer. So this 300 is integer in Python. In order to convert it to double, you just need to add a dot and then a zero. So this is automatically will be converted when it's interpreted in the software. It will convert it to float. If you delete the zero and the dot, this is converted back to integer. So Python does that for you. So it's very easy to work with data types in Python. So let's go ahead and try to plot these two lists. Okay. In order to plot anything in Python, you need to import some plotting library, because there's something you need to know. Python, by the default, does not provide anything to plot or anything to manipulate, let's say, data tables. You need to use some third-party libraries that can provide this functionality. And this functionality can be found in a library called Matplotlib. So in order to import that library or start using it, you need to use the keyword import. And then you will write the library name in the library name. And then there is something called pyplot. So you need to access pyplot like this. So pyplot is a class inside the library called Matplotlib. So this class actually, this is the main class that provides you the plotting functionality. So the convention is you don't need to type all of these whenever you are using this functionality method. There is a keyword in Python called as. So this is to give the library a name. So this is the convention to name it as PLT. So what this does mean, it means that import a library called Matplotlib. From that library, import pyplot only, and then name this as PLT. So this as is just giving a name to the library. So you don't have to type this long name. So in order to plot anything, you need to just type PLT dot plot, and then open and close parentheses. We need to pass X and Y values to it. So X and Y, this is how it's written. However, my variable names is not X and Y, it's oil days and oil production. So I will put oil days on the X axis, oil underscore days. And then I will write comma and pass Y list to it, oil underscore production. So whenever you run this, you should get a plot similar to something similar to this. So this is the plotting functionality inside Python. You can do a lot of things with this plot. Actually, you can add multiple lines to the same plot. Just type PLT dot plot, and you can pass the data to the next line or the next series. I will just copy this oil production and call it water production. Let's change some of the values. Let's call this 10, maybe 15, 150, say 350, and 5,000. Now I need to plot this water production with the oil days. Since the days are the same, I don't need to create X variable anymore. I will use this in conjunction with water production. So I will pass oil days, and I will pass water production to that as well. So whenever I click run, now you should get 2 lines in the plot. So you can do this as many times as you like. You can plot a lot of lines. Maybe you can even plot hundreds of lines inside this library. This is a very nifty library. So in order to view the history of the plotting or the history of the commands that we run inside the Spider software, you just need to scroll in the console. So these are the history of the run. So these are my 2 plots. There is another nice feature inside Spider. It takes up the plots that's being shown in the console and just isolate them in this plot tab. So this is very, very useful. If you are like me, sometimes these plots, this is just not the resolution we like, because the plots are just small. We need to create something bigger, like more resolution. What we need to do is just change the size of the plot. How we can do that? We go ahead before the plotting. This is very important. You go ahead before you doing any plots. Maybe you can go here or here. It depends on you. Actually, whatever settings I have, I usually put it in the before beginning of the any sheet. So to change the size, what you need to do is just call this figure equals to plt dot figure. So what a figure is actually is this the white thing, the container that contains all the data. This is known as a figure. So there is an optional parameter you can pass inside the figure. It's called fig size. By the way, this is just, you need to memorize this. So let's create a figure that's 8 by 8, and then just click run. Now you can see the figure got a bit bigger. So this is, you can just make any aspect ratio you like. For example, 8 by 10, or maybe let's do it 16 by 9, and click run. As you can see, whenever you are clicking run, it's already being updated. So sometimes you would like to add some grids to this plot because it's just white. What you can do is plt.grid, open and close parentheses, and that's it. The grid will start to show. Just click run. Now we have added grid to it. As you can see, our plot is missing title. What you can do is just add some title to it. You'll write plt.title, open and close, and then you pass your title to it. For example, I am saying my field X production. Just click run. Now you have been added title to that as well. What you can do is you can save this plot in PDF format or any format you like. For example, PNG, JPEG. But the thing, I worked with Matplotlib a lot. Whenever you are exporting this plot as PDF, the resolution of the plot will be very high. So let's go ahead and try to export this as PDF. So I write plt.save fig. So this saves the figure. So it means it saved the plot for us. Just provide a name to it. Let's go call it my fig.pdf. So you provide the extension to that as well. So whenever you click run, to view the exported file, you go to Files tab. Once you go to the Files tab, now you have your PDF, myfig_pdf, .pdf, sorry. So you right-click to it, and you go to the option Open Externally. And now it's open it in it will be opened in the PDF. So you can zoom in and you can see the resolution of the plot. The resolution actually is very impressive. Let's go ahead and try to take another example inside Python. Let me just open another sheet. I'll just right click anywhere, Python file. Let's call this as contour map. So I'll try to plot a contour map. Just save it. Now I have this empty file. Actually, I have a file that's known as demo x and y. I'll try to provide this file to you guys. This file, actually, I've imported this from OFM. It contains a lot of information about the wells, the completion names, the zones, the unique identifiers, the aliases, the depths. A lot of information is included in this. So the three most important information I'm interested in is the unique ID, or the name of the well, X coordinates and the Y coordinates. These are very important to me because I will try to use these and to create some maybe some contour maps for the well. So what I'm going to do is just I will move this file. I have this file sitting somewhere in my computer. I will just copy it and just paste it to the place I created the contour map.py. So in order to open the location of this file, I will just right click on my file, contour map. I will go to this option, show in folder, click on it, and it shows me the folder that this file resides in. I will just paste my file. Now I have something called demoxy.txt. So we need to import this data. By the way, if you are trying to import this file using pure Python, this is going to be very messy and it requires a lot of time and attention from your side. So luckily we have a third Python library called as Pandas. Pandas allows us to import files and convert these files into data tables. So I will import Matplotlib because I'm trying to plot contours .pyplot as PLT. And I will import Pandas, import Pandas. This is Pandas is written like this as PD. I'm meaning here import the Pandas library and call it PD. So whenever I write PD in my code, so I don't need to call Pandas. So this is just aliasing or renaming the variable, or so renaming the library, sorry. So let's go ahead and import the file. How to import the file? First of all is to create a variable where the file contents will be saved. So the convention is to call this is call it as df. Df is short for data frame. It's a table, by the way. A data frame is a table. Equals to. There is a very nice functionality inside Pandas. It's called read CSV. So I write PD dot. Whenever you write dot, actually you're trying to access the internals of the library. So there is a nice functionality called read underscore CSV, open and close parentheses. In this, I will try to pass the path to my file. So since the Python file resides on the same folder as the demoxy file, so I don't need to specify any path. This is known as a relative path. So I'll type the file name directly, demoxy.txt. Now, since my file is not separated with the commas, as we saw, we need to specify what's the type of separation in this variable in this file. So there's a nice option inside the read CSV method. It's called SEP. SEP means the type of the separation. I will provide this this string. This is known as it's separated as tabs. Okay. So let's go ahead. Once we import this, let's go ahead and print our data frame or our data table. Click run. Now those are the data that's being imported. So if we go ahead and go to Variable Explorer, we'll find the data frame is being already imported. If you double click on the values, it will list a nice table for you. Okay, so this is the table we've already imported. So this is a very nice functionality inside Spider. Let's go ahead and try to plot some maps for this. I will define X, Y, and Z. X will be the X coordinate of the well. Y will be the Y coordinate, and the Z will be the total depth of the well. So I'm trying to create something like the depth maps of the well. So in order to access a specific column inside the table, you open and close the bracket, and then you pass the column name. So let's go ahead and explore the column names. We'll go to the variable explorer. So the column name is called x coordinates. So it's written like this: x coordinates, x coordinates. I will take this as, I'll copy it as y. Now we have the y coordinates. Okay. If we go ahead and plot this, it will show us the location of the well. Let's go ahead and do that. So plt dot scatter. Now I will call a function called a scatter. This is the same as dot plot, but this is only plots the dots. It does not connect the dots. So x, y, and this is extra, the keywords. So I will just run. So this is telling me this is not correct. So this is capital C, just run the file. Now you see I have this map. However, this map is ugly. It does not show you a lot of information. I would like to show the depth as a contour. So in order to get the depth, I will provide another value, a variable called depth, equals to data frame, open and close bracket. There was a column called total depth. I will try to plot that as a contour. So you see, this is the total depth. I will type total depth. And then I need to change my plotting functionality. So I will delete this scatter. I will provide a new method of plotting. It's called as try contour. This is try contour. Actually, it provides contouring functionalities for Python. I'll provide 3 variables, x, y, and depth. So whenever we should hit run, we should have the contour map. So this is the contour map we got. To show the well locations on this contour plot, actually, we will plot the wells as well, like this, plt.scatter. It's the same, just the same expression we had, just the same line, x and y. Just run it again. Now we have the well location shown. In order to show field map or field contour, we just add the letter F after contour. So it will be try contour F. F actually stands for field. Just we run it again. Now we have this contour map. Actually, it's not pleasant to see the well locations as the same color as the map. So we will need to change the color of the wells. So we will provide a argument to the scatter. It's called color. So this will color the well locations for us. I will call it black. You can call it red or whatever color you like. So now we have the well location. So this actually concludes our webinar for the day.